Why should I make a copy of a data frame in Pandas? When selecting a sub-data frame from a parent data frame, I noticed that some programmers make a copy of the data frame using the .copy method. For example, instead of just. Why are they making a copy of the data frame? What will happen if I don't make a copy?
This answer has been deprecated in newer versions of Pandas. See docs. This expands on Paul's answer. In Pandas, indexing a data frame returns a reference to the initial data frame. Thus, changing the subset will change the initial data frame. Thus, you'd want to use the copy if you want to make sure the initial data frame shouldn't change. Consider the following code. You get. In contrast, the following leaves df unchanged.
Because if you don't make a copy, then the indices can still be manipulated elsewhere even if you assign the data frame to a different name. For example, func1 can modify df by modifying df2, so to avoid that,
it's necessary to mention that returning copy or view depends on kind of indexing. The Pandas documentation says, returning a view versus a copy. The rules about when a view on the data is returned are entirely dependent on number py. Whenever an array of labels or a Boolean vector are involved in the indexing operation, the result will be a copy. With single label / scalar indexing and slicing, e.g. df.9, 3:6, or df.9, a view will be returned.
The primary purpose is to avoid chained indexing and eliminate the setting with copy warning. Here chained indexing is something like dfc, 0 = 111. The document said chained indexing should be avoided in returning a view versus a copy. Here is a slightly modified example from that document. Here the acolumn is a view and not a copy from the original data frame, so modifying acolumn will cause the original dfc be modified too. Next, if we index the row first, this time 0_row is a copy, so the original dfc is not modified. From these two examples above, we see it's ambiguous whether or not you want to change the original data frame. This is especially dangerous if you write something like the following. This time it didn't work at all. Here we wanted to change dfc, but we actually modified an intermediate value dfc.loc, 0, that is a copy and is discarded immediately. It's very hard to predict whether the intermediate value like dfc.loc, 0, or dfc, is a view or a copy, so it's not guaranteed whether or not original data frame will be updated. That's why chained indexing should be avoided, and Pandas generates the setting with copy warning for this kind of chained indexing update. Now is the use of .copy. To eliminate the warning, make a copy to express your intention explicitly. Since you are modifying a copy, you know the original dfc will never change and you are not expecting it to change. Your expectation matches the behavior, then the setting with copy warning disappears. Note, if you do want to modify the original data frame, the document suggests you use LOC.
Assumed you have data frame as below. When you would like create another df2 which is identical to df1 without copy. And would like modify the df2 value only as below. At the same time the df1 is changed as well. Since two df is same object, we can check it by using the ID. So they are same object and one change another one will pass the same value as well. If we add the copy, and now df1 and df2 are considered as different object, if we do the same change to one of them the other will not change. Good to mention, when you subset the original data frame, it is safe to add the copy as well in order to avoid the setting with COPA warning.
If you want to support the channel, please consider liking and subscribing.